All right, so now I want to look at three problems using geometric series. And so we want to determine if this series converges or diverges. So the first one is 6 to the n over 5 to the n. So for this one, we want to figure out what is our a and what is our r. So for this, it might help to write out the first few terms. Notice when n is 0, we get that this is just 1. And when n is 1, this is 6 over 5. Next one is 6 over 5 squared, so on. So from this, we should be able to see that our a, the first term here, is equal to 1, and our r is equal to 6 over 5. And so note that our 6 over 5 is greater than 1. And so because it is not between -1 and 1, the series diverges. In the next example, we have -2 to the n over 3 to the n. So once again, we get that this first term is 1 because we're starting at n equals 0. Then the next term is going to be -2/3 plus 4 over 9 minus 8 over 27, and it continues like this. So our a, once again, is the first term. And then our r, this is the term that we get by multiplying one term to the next. And so for each term here, it's multiplied by -2/3. So our r is -2/3. Now, because the absolute value of -2/3 is less than 1, we see that this series converges. And we can use our formula a over 1 minus r to figure out what this series converges to. And this is 1 minus -2/3, which gives us 1 over 1 plus 2/3. You can get 1 over 5/3, or 3/5. And so we get that this series converges to 3/5. And so for this third problem, we get 1 over 4 to the n. So once again, if we write out the first few terms of this sum, so now we're starting at n equals 1. So our first term is 1/4. Next one is 1 over 4 squared, which is 16. Then 1 over 4 cubed is 64, and so on. And so we get that our first term now is 1/4, and our r is also 1/4. So because the absolute value of 1/4 is less than 1, series converges. And if we want to figure out what the sum of the series is, once again, we can use our formula. So the sum of these terms is a over 1 minus r, which is 1/4 over 1 minus 1/4, or 1/4 over 3/4, which is going to be 1/3. And so we get that this series here converges to 1/3.